Tiab and his work presented with Kasper Hornbæk. So understanding affordance, system state, and feedback in shape-changing buttons.
So thanks for the introduction, and I'll be presenting this work. It's done with Kasper Hornbæk from the University of Copenhagen and as part of the GHOST project. So shape-changing interfaces are interfaces that could use physical shape change as means of input and output. And this dynamic nature gives them the possibility to offer new interaction techniques. And most of recent work have been focusing on developing and building those interfaces in order to take advantage of this dynamic nature. And this have resulted in shape-changing mobile phones, pneumatically actuated interfaces, and shape displays. Although we're getting better and better in developing and building those novel user interfaces, still our knowledge of their user experience is still limited. In particular, we don't know well how users perceive and react to shape change. So, and some work have been focusing on that. For example, in the paper "Is My Phone Alive?" The authors measured the users' reactions of some of videos of a shape-changing handheld devices, where they changed systematically some shape-changing parameters and measured the effect on users' perceptions of urgency, animacy, and effect. And in another study that was a repertory grid study, the authors measured the participants' responses to a set of shape-changing artifacts, where those artifacts manipulated volume, texture, and orientation. And co-motion was a shape-shifting bench where the authors used it in the wild study in order to observe the effects of using it on social situations and contextual atmosphere. However, the existence of these studies, some of the core elements of user experiences are still not well understood. So, for example, dynamic affordances and feedback. So, and dynamic affordances is one of the key elements of user experience in shape change, which was introduced in Inform using the term that it's used dynamic physical features in order to guide the users on how to use the system. So, and as an example that was mentioned in Inform, the system could change from a button to a slider to a 2D tracking surface in order to guide the user how to better use the system. And that's actually what we focus on this work. So we try to present an in-depth empirical user study of affordances, system state, and feedback in shape change. And we do this through using shape-changing buttons. So basically, we developed some shape-changing buttons, and we ran a study in order to understand how users perceive and act upon those buttons. But you might be wondering, why buttons? And for this, we have two reasons. First, simplicity. So buttons is one of the simplest and most ubiquitous UI elements. And by exploring a user experience of shape change using buttons, we try to reduce the complexity and novelty effects that's usually accompanied with shape-changing interfaces, and which will make us focus more on the user experience of shape change. And the second thing that button encapsulate well the three things that we want to study: affordances, system state, and state change feedback. So a good button design of a machine should tell me how to use it and if the machine is currently on or off, and after I press it, what was the effect of my action? So hence, affordance, system state, and state change feedback. So mentioning what we did and why we do it. So now let me tell you how we did that. And we used in our study some shape-changing buttons, and we designed 10 of those that mimic a horizontal toggle button. And as you can see, the designs were simple. We didn't have a radical shape change, but we used some actuation in order to have some shape-changing behavior that could provide affordances and feedback. And we implemented them using mechanical and pneumatic actuations, which are the most commonly used in shape change right now. So, and some of the implementation details, so the mechanically actuated one, we used a motorized fader that could be found in some of the sound mixers. And we added on top of it 3D printed handle, and we coated that with conductive ink so we can detect capacitive sensing. And we used an Arduino board in order to control the motion of the handle and also for sensing the touch interactions. And for the air button, the pneumatic control system consisted of some valves, where by opening and closing them through 5 holes along the button, we control the animation or the flow of the air throughout the button, and we can mimic some affordances and feedback using that. And for the touch, for sensing touch, we used a piece of zebra conductive fabric, where it has some strips of conductive and non-conductive pieces in order to achieve separate areas of conductivity. And also we used an Arduino board for the sensing and for controlling the pneumatic control system. And here, let me give you an overview of the 10 buttons that we used. So we used invite to touch buttons, feed forward buttons, on approach buttons, and animated feedback buttons. And we based our designs on previous work of shape change. So for example, the on approach interaction that was mentioned in Animate Mobiles. And also we got inspired from successful techniques of affordances and feedback and other UI elements. For example, vibration movements and feed forward that they are used in handheld devices in the applications and the UI of them. And now I'll walk you through each of those buttons. So the invite to touch buttons use vibration movements, as you can see, horizontal and vertical, in order to hint the affordance of interaction to the user. Feed forward uses a small animation in order to hint the direction of interaction for the user. Where you can see on the left, it kind of moves and gets back. And with the air one, there's a big bump and then smaller ones in order to hint the direction of interaction in this way. The on-approach buttons react to the hand approach of a user in order to hint and stimulate interaction. And lastly, for the animated feedback, we had 2 styles, linear animated feedback and decaying. For the linear, we used a simple animation where just the button toggles from one side to the other. And this is in order to say that the button switched from on or off or vice versa. And the more fancier one, the decaying one, we used it, for example, for the mechanically actuated one, that it's kind of shows the effect of a bouncing ball, like the button is moving to the other side in a bouncy way. And the air one used fluctuating pulses in order to go to the other side in a decaying form. And here in the animated feedback, we use two styles in order to see the effect of varying the animation feedback on the perception of the state change feedback. So when the button changes from on or off, or vice versa, what would be the effect of those animations as kind of feedback? And for the user study that we performed, we ran this user study in order to obtain the participants' perception of affordance, system state, and state change feedback, as I mentioned before, using the buttons that I mentioned. And those perceptions were obtained via Think Aloud protocol, and where we focused on those specific 3 things. And our assumption was that by doing this, we can learn more about the user experience of shape change using those shape-changing buttons. So the study design went something like this. So we actually had 13 buttons, so the 10 buttons that I just mentioned, and we had 3 baseline buttons where they were non-interactive. So the first one was just a plain piece of fabric, and the next ones had with no handle at all, and the next ones had non-interactive handles where they didn't respond to the interaction of the user. And we used this as a baseline in order to see what's the effect of the shape change on the user's perception. And we had 15 participants, where 6 of them were females, with the age range from 23 to 34 years old. And none of the participants had previous knowledge or interaction with the shape-changing interfaces before. The study setup was something like this, where we had the two prototypes present, but we had only one active at a time, where we allowed the users to perceive it and interact with it. And the order that we chose was random, and the study procedure went something like this. So first, we made one of the buttons active, and then before the users could touch the button or interact with it, we asked, is the button on or off, in order to ask about the system state. And then we asked, how would you use the button, in order to ask about affordance. And then we let them use the buttons freely while thinking aloud, in order to capture their comments and thoughts about how they perceive and use the buttons. So hence we use the three things that we want to see: system state, affordance, and feedback. And we used audio and video recordings in order to capture the participants' comments and interactions. And afterwards, we transcribed those videos, annotated them, and analyzed those videos. And with the analysis, I'll be mentioning some of the most prominent results that we got out of that. And the first thing that we noticed, that affordance is hard, as for example, that mentioned in the previous talk. So vibration movements were good in grasping users' attention, especially that the buttons moved without the users interacting with it. But it led to some misinterpretations. So not always it was the case that users thought that those are invitation for movements. However, sometimes they thought that the button is kind of stuck and it doesn't want to move to the other side, or that the button is signaling an error, that it's kind of overheating, or there is danger with the system. The second thing that we noticed, that feed-forward failed in hinting affordance. So most of the users didn't see the feed-forward animation as an affordance signifier, although they saw it kind of a system state feedback. So they thought that this movement told them that the system is always processing or going through data or handling data. And also interacting with the feed-forward motion. So instead of following the motion as we anticipated, actually you can see here in the video that the user is trying to restrict the motion or stop it to the other side, instead of following it to the correct side. So they were actually telling, okay, now it's moving, but I want to stop the motion instead of following it. And for the animated feedback, we saw that it enhanced the look and the feel of the buttons, especially the air buttons. Users commented that it made it more tactile and better, because it didn't just stop from one side to the other, but it had some kind of a flow. And we saw also that animated feedback conveyed information about the process of state change, not only that the system changed from on or off, but the process of the system going through this. So for example, if the animation was fast, that means that the system didn't have any problem going from one state to the other. Or if it was a bit slower, then the system had some delays. It's some kind of the analogy of a progress bar, for example. And after mentioning those results, let's see how those results could mean for a broader perspective of shape change or for future work. We acknowledge that in our study we used a pretty simple design. We used toggle buttons, and however it was so simple, and the interaction span was so short, so it's just toggling between two states. It seemed a challenging problem in order to design good affordances and feedback for that. So you could imagine how would it be the case for more complex interfaces. And that raises the question that we need more user experience studies in order to better understand how users perceive and react on shape change. And hopefully this will lead to some better design guidelines that would help us design shape-changing interfaces. The second thing that we noticed, that shape change is not suitable for simple feedback. The feedback that we wanted to convey using the buttons is on or off, and sometimes we saw that shape change overloaded this feedback and led to some misinterpretations and ambiguity. And this raises the question of when to use shape-changing feedback and when to use a simple visual like an LED or just a simple label. And this is still it's not explored when to use what. And the third and last thing that we noticed, so through these interactions, as I mentioned, users wanted actually to stop the motion. So shape-changing interfaces could design some animations or motions that's based on stopping to interact. So instead of following the motion, you interact with the interface by stopping it. It's like interacting with your alarm clock. You interact with it through stopping it. And so in conclusion, we presented an in-depth user study of understanding affordances, system state, and feedback of shape change. And although we used a simple interface in our study, the study revealed that the question on how to design good affordances and feedback for shape change still remains a challenging question and that needs further studies and investigation. With that, I would like to thank you for your attention, and I'll be happy to answer your questions.
Hi, Roll Vertigo. Very nice work. Don't you think that sort of there is kind of a mispremise here that motion, which is the result of shape change, could be used as an affordance? Because I think in static physical affordances, it's almost always about shape. And don't you think that that's why you got the results you got? And you know, also motion is very often associated with anthropomorphication, like something is alive. And I saw a lot of the comments were sort of about that. Yeah. So if you had a traditional on-off toggle switch, you know, you convey that affordance by sort of having this sort of like seesaw effect, yeah, right? And how you can fit your hands to it. And you're almost like counteracting that by having this thing move. And that's why people are trying to stop it, right? So to what extent, like I think the challenge is in dynamic shape interfaces, you can't always suggest a shape as an affordance because the shape may not exist yet, right? So what do you think in terms of future directions, like in terms of examining more shape or showing different possibilities for shape somehow so you can have many affordances but somehow the users would see all of them simultaneously?
Thank you for this. And as you mentioned, we weren't concerned about how the affordance of the shape itself. But
could you speak in the microphone?
Sorry. We weren't concerned about the shape of the thing itself because it was pretty known, the shape. But we focused more on the animations that we can change this. And this we use because the shape-changing interfaces afford this dynamic feature of having change. So we used these animations in order to see if they would enhance the affordances and feedback or not. So we're mostly focused on the animations and the changes, not on the
yeah, my question is isn't it a better direction perhaps to go for the shapes?
Yeah, or maybe could I follow up with
sure.
Kind of related point, just going off of what Roll was saying. I wonder how much of the effects you're seeing are based on the visuals of the motion alone, and I think it would be nice to see a comparison where you have just the same animations you have with the same 2D shapes, or even looking at it, I guess the same 2D shapes on a display there and comparing that, because it seems like a lot of the things. It'd be interesting to know how having it be physical changes the motion and how people perceive that. So maybe that gets...
Yeah. As I think lots of future work to be done.
Thanks for the question.